So, good morning, everyone in Germany. Good morning, everyone in Vietnam. I hope you hear me and that translation is working. Dear colleagues and friends, it's a great honor for me to moderate today's webinar as a joint effort between CAMaRSEC project and the Mien Trung University of Civil Engineering, MUTSE. The preparation of this event took us several weeks, and I would like to take the opportunity to really thank all of our colleagues from MUTSE and for my team. So let me continue with my introduction. So we can start the clip again from now. First of all, I would like to express my deep gratitude to Dr. Chan Thi Lan An, Vice Director of Urban Development Agency at Ministry of Construction. Dr. An will provide a keynote lecture on the topic of legal framework on promoting climate change adapted and sustainable urban development in the central coastal areas of Vietnam. Second, I would like to thank Mr. Sorry if I don't speak it out correctly, Mr. Huyen Lu Tan, the Party Committee Secretary of Phu Yen Province Government, for providing us the honor to give a welcome address to this event. This shows the strategic relevance of our webinar and is really very much appreciated. Third, I would like to thank Dr. Nguyen Vu Phuong, Rector of Mien Trung University of Civil Engineering, to provide a welcome address as well. This shows the strong commitment of MUTSE and its interest in establishing a fruitful cooperation with the German research partners based on mutual respect and trust. Last but not least, I would like to thank Mr. Andreas Gruner of GIZ, the German International Cooperation Agency, representing the donor community. Andreas will present about an initiative of GIZ to promote green buildings. Our whole team from CAMaRSEC project regards today's event as a great opportunity to connect to a new higher education partner from central Vietnam. Today's event will facilitate to get to know each other as well as to learn and to understand more about everyone's expertise. Hopefully, this is a starting point for establishing new and innovative partnerships against the backdrop of future calls of funding in the field of green buildings and sustainable development in Vietnam. In normal times, such an event would also be a perfect opportunity to share some food and maybe German beer together. It's really a pity that this is not possible right now. But please be assured that we will take the first opportunity to travel to Vietnam as soon as possible to meet all of you face to face. We will have a welcome address from Mr. Tan, Party Committee Secretary of Phu Yen Province Government, and from Mr. Nguyen Vu Phuong, Rector of Mien Trung University, followed by a welcome address by Dr. Dirk Schwede, Stuttgart University. He's the CAMaRSEC project leader. Then we will have input from all team members from CAMaRSEC project, from Stuttgart University and Vietnamese colleagues, from Hamburg University and Vietnamese colleagues, and from Fraunhofer Institute and Vietnamese Institute of Building Materials. Then we will have Andreas Gruner, who will introduce about an initiative from Germany trying to support green buildings in Vietnam. Please switch the slide. Go to the next slide. And then originally the plan was to have a keynote speech of Ms. An, Vice Director of Urban Development Agency for Ministry of Construction. She had to cancel her presentation because she has other obligations right now. But please be assured that we will share her presentation as a full PowerPoint presentation after the event. Then we will have a talk by Mr. Phuong, director of MOODSET, who will present about challenges and opportunities to promote sustainable buildings in central Vietnam from the urban planning and urbanization prospect. And this will be followed by several inputs by staff members of MOODSET. First presentation would be by Mr. Hien, Head of Faculty of Architecture, who will present about spatial organization of coastal village of southern central region towards sustainable development and adaptation to climate change. Then we have a presentation by our colleague Ms. Tu, who will present about resilient housing to natural extreme events in the coastal central region of Vietnam. And then we will have a presentation by Mr. Dang Quoc Viet, who will present about eco-friendly concrete incorporating supplementary cementitious materials at coastal areas. Last but not least, this will be followed by a Q&A, an open discussion, which will be facilitated by my colleague, Dr. Tu Nguyen from Hamburg University. Wrapping and closing will be done by Mr. Phuong, a director of MOODSET. So I'm very much looking forward to our seminar. Let me say a few words in my basic role as a moderator. Because our event has only limited time and because there are so many interesting insights to share, we would like to kindly remind our speakers to pay regard to time management. Less is often more. We will share all of the presentation files as mentioned before later on. So please be focused and concise. I will warn you about 3 minutes before the end of your presentation to come to an end soon. Your understanding of this is very much appreciated. So let's continue our joint webinar with the welcome address of Mr. Tan, the Party Committee Secretary of Phu Yen Province Government. Mr. Tan, please change the slide, Tui.
Good afternoon.
Good morning to all colleagues and partners. First one, on behalf of the Miền Trung University of Civil Engineering, I would like to send my special thanks to the CAMaRSEC projects and the organizing this webinar on the challenges and opportunities of promoting green buildings in the coastal areas of central Vietnam, potential to cooperate with the CAMaRSEC project. And this is an event where we look forward to the collaborations for the climate change action and other similar actions in the central coastal areas of Vietnam. I would like to send our special thanks to the leaders of the Ministry of Construction and relevant department in the central area of Vietnam and the speakers and in spending time to share with us your insight into the urban issues on the urban areas in the central area of coastal Vietnam, central Vietnam. I have received here we can see that the participants from different agencies, including the agencies of urban development, the Institute of Architectural Studies. From the north, we have representatives from Hà Tĩnh, Quảng Bình, and from the central, we have representatives from Đà Nẵng, Huế, Phú Yên, Ninh Thuận. From different universities, we can see Dr. Lưu Ngọc Vinh, directors of the University of Architecture of Hanoi, and many other representatives and experts in the architectures and planning. And we are very sorry about the incident that prevents some of the participants from attending the remaining part of the webinar. I myself have participated in 3 other webinars recently, and there were also technical problems similar like this. So so it's very important that we ensure the security in online working and online seminar like this for us, and it happens for us at our university. We have been conducting online learning over the past semester, and it's very important. Some more information about the Miền Trung University of Civil Engineering. we are civil. We have different discipline, and we will be a part of the phase 2 of the CAMaRSEC project to identify the solution for sustainable buildings in Vietnam, and which is a collaboration effort between CAMaRSEC projects and the Miền Trung University of Civil Engineering. And we would like to extend our sincere thanks to all of the participants and representatives from different agencies and departments and university for spending your time to attend the webinar today. And I would like to wish our webinar a great success. Thank you.
Thank you for your great welcome talk. Tui, please move back to the start of the welcome address of Dirk. And then now I would like to ask Dirk to give his welcome address. Dirk, the floor is yours.
Yes, thank you, Michael and Tui, for organizing this, and thank you for recovering so fast. I don't want to talk about the incidents, but I want to use the opportunity to first extend our willingness and express our willingness to cooperate on the topic of green and sustainable building in Vietnam, and also with, of course, with the University Mutze. I'm here speaking from the University of Stuttgart as a leader of the CAMaRSEC consortium. The CAMaRSEC consortium is a group of researchers from Germany and Vietnam, and we are working in a project, thank you, funded by the German Federal Ministry of Education and Research. And we are working on sustainable building from many perspectives, and you will hear a lot of details and also first results about the project. We have here the research consortium. I just want to introduce University of Stuttgart. This is my group working on the technical issues. Then we have University of Hamburg, who is working on capacity building, on governance issues. We have the Fraunhofer Institute for Building Physics, which is a research institute in Germany, very specialized in building physics research. We have Baubildung Sachsen, who is working on education and training of construction workers, which is also an important field. And we have as industry partner Netz Taurus. In Vietnam, we are working together so far with Hanoi University of Civil Engineering, Tong Duc Tan University in Ho Chi Minh City, and the Vietnamese Institute for Building Materials and the College of Urban Work and Constructions. And you will see our joint results and work in the following presentation. Next slide, please. Yes, we address the topic here of sustainable material research. There is a lot of change going on, and the objectives in the construction sector are changing. Here, for example, the new energy building code for high-rise buildings in Vietnam. At the same time, also the construction methods and the materials are changing, and this is the topic of our research. We want to understand how state-of-the-art and modern construction can be introduced in the demanding climate of Vietnam. It's hot and humid, and at the same time, also the use of building is changing. So there are a lot of questions to answer, and we are working together in our CAMaRSEC project to make a contribution that sustainable building is enabled in the construction sector in Vietnam, and that some of these questions are answered. Next slide, please. Yeah, we have some work packages here. Work package 1 is on fundamental data and the social economic context. This is mainly driven by Hamburg University, by Michael and Tui. And then we have a lot of measurement where we go from the engineering perspective towards understanding how buildings are operated, how they work, but also how construction materials, which performance construction materials can have. We have other work packages here where we look at governance, where we look at capacity development, and then also we have, of course, a frame with conferences and the advisory board. Yeah, here just some insights. I think this will be discussed and presented in more detail by the colleagues of Fraunhofer Institute. We do research and classification of building materials. We also look at the environmental impact of building materials. So we do life cycle assessment studies on materials which are used in Vietnam and try to develop this basic knowledge so that we can look at the life cycle of building materials. The next slide. We also do, together with Hanoi University of Civil Engineering, extensive measurement in buildings so that we understand how buildings are operated, the climate conditions in buildings, and also how much energy is consumed in buildings. Here you can see an example of the work of Baubildung Sachsen and also the College of Urban Work and Construction in Hanoi. This is on training of construction workers. And here we try to implement the findings of the other work package in curricula for construction workers. We also have a competence center for sustainable building in Vietnam, which is organized also by Hamburg University and by Hanoi University of Civil Engineering. And of course, we have a web page where we publish our results. Yeah, please contact us, and we are looking looking forward to working with, of course, more colleagues also in different regions of Vietnam, so that our research and the results of our research are more valuable and more applied in the context of the Vietnamese construction sector. Thank you for your attention.
Thanks, Dirk, for providing this comprehensive overview of the CAMaRSEC project. Much appreciated. Actually, the floor is yours now once again, but now you will present the more content-based scientific approaches of the sub-project from Stuttgart University. So please, Dirk, just continue with your presentation. Thanks so much.
Yes, thank you. I will now present some details of our work, which is not only, of course, of Stuttgart University, but which was supported and is also carried out to a large extent by the colleagues of Hanoi University of Civil Engineering and also Trong Duc Tan University from Ho Chi Minh City will have a part in the same exercises in future. Here you can see a measurement campaign where we did measurements in long-term measurements in a number of houses and apartments in Hanoi, 49 houses in 15 residential buildings, where we measured for 1 year the environmental conditions. Then in a subset of these buildings, we also did a detailed measurement of comfort conditions. And all this has the purpose to develop knowledge about the indoor climate and the user behavior in buildings in Vietnam. We found that there are some differences. Some people are conditioning the apartments to a large extent. Some people work with natural ventilation, and that, of course, leads to different energy consumption in these buildings. This is very important to know when we design new buildings and when new buildings are designed. And so we hope that with our findings, we can provide knowledge on this user behavior in order to design optimized buildings for the climatic context in Vietnam. Yeah, here you can see again some pictures how this was done. We had the long-term measurement with the data loggers, which you can see here on the left side. And then we had the detailed measurement with more comprehensive equipment. And this is then turned into data and understanding of the indoor behavior and the indoor climate, which is then used, as I said, for building investigation. And the aim is to produce here use profiles and also conditioning behavior knowledge, so that in future the building design can be optimized based on real data, real measured data from Vietnam. The next slide, please. Another important part is that we optimize and understand the environmental impact of the production of building materials. There is a change, as you will know, in the application of building materials and building systems in Vietnam going on recently, from burned bricks to non-fired bricks. And our aim in this work package is to understand the environmental impact of production processes and to support also producers of building materials to improve the processes of material production. So we carry out long life cycle assessment studies on traditional and alternative building materials. The next slide, please. Yeah, this is now modeling of the LCA study. We apply software tools, which we also use in Germany to produce environmental product declarations. And the aim is to produce this information and this modeling for a number of materials which are currently used in Vietnam, so that this could be the starting point of a database on building materials and their environmental impact in Vietnam. The next slide, please. This is now provided by our colleagues from Baubildung Sachsen. They are working on vocational education and training and capacity building. The aim is to set up a train the trainer program. They are currently analyzing the curricula of the College of Urban Work and Construction. And then they look at our research results from the other work packages and see what needs to be included in the curricula for building professionals, so that the construction workers can produce state-of-the-art modern buildings which are durable, which can sustain the climate in Vietnam. And what is also important, the construction workers are taught how to work with the new materials, for example, the unburned bricks, so that there's no building damages after construction. And this is very important also to close the loop and to achieve trust in these new technologies. So it was very important for us to have also this in our framework for the CAMaRSEC project. Yeah, they are, as I said, they are looking at a training concept, developing a training concept for the College of Urban Work and Construction in Hanoi. But of course, this training concept can also be rolled out to other training centers. And the aim is to develop a train the trainer program, so that also the multiplication of the results of the project is very large, and that the benefit from the results can be very wide. What is important, just to summarize, our project is continuing for another 18 months. We had to extend the project by 1 year, so we have time to 2023 in June. We hope that we can continue with some measurement on site, that we can travel again, but altogether we have already some interesting results which the colleague will present in the next presentations. Our aim is to do research for real application, and what came to our attention is that we need fundamentally relevant, locally relevant data, evidence-based methods for the evaluation, and we need also skills to advance sustainable building practice in Vietnam. And we hope that our CAMaRSEC project can make a contribution to that, and we hope that we can work together with many colleagues in Vietnam, also other universities, to achieve this goal. Thank you very much for giving me the opportunity to present this.
Thank you, Dirk, for your very insightful presentation, which will be shared later on with the audience and other interested parties. Let's continue with sub-project Hamburg University. And Tui, you seem still a little bit shocked, so I would suggest I do the presentation on my own and you just switch the slides. I stick to your manuscript, of course, word by.
Yeah, as you wish.
Yeah. Okay. So dear colleagues, on behalf of the whole CAMaRSEC sub-project Team 2, consisting of researchers from Hamburg University, Hanoi University of Civil Engineering, please stick with the first slide, and of Tongluk Tan University, my colleague Tui, as planned, and I would like to present about our specific research and dissemination activities embedded into our theoretical framework. Next slide, please. So, by means of this graph of the scales, we would like to illustrate that despite Vietnam's strong environmental commitments and despite even an existing energy efficiency building code in Vietnam since the year 2008, which has been even revised twice already, the total number of sustainable buildings is still negligible, only around 200, compared to the tremendous amount of ongoing construction activities. So the key question is here, why? Why the scale is not even? Why there's such a huge gap between existing policies, regulations, and current building practices in Vietnam? So we try to get closer to the answer by referring to two quotes from world-famous scientists in the field of sustainability research. The first quote says, "Sustainable urban transformation is not only a technological challenge, but also a social, cultural, economic, and political one." With our background as social scientists, we can only support this view. So we see our active role in bringing together the engineering and the social science perspective. And we do this not only within CAMaRSEC, but within all other projects in the region we are involved to. We do this because we are firmly convinced that a successful sustainable urban transformation has to put the people at the center, to understand their socio-economic conditions, their cultures, and their behaviors. The second quote says, "Such challenge requires transformations on multiple levels, from individuals to national and global politics, to cultural patterns and to macroeconomics." It highlights the need to pay regard to different levels and to different stakeholders. Governance is more than government. To implement sustainability approaches, even in the field of sustainable building materials, which is quite a technical matter, we have to analyze stakeholder settings and pay regard to the socioeconomic context as well. So let me summarize. Not yet, please stay there. The implementation of sustainability approaches cannot be achieved just by implementing technology. It can only be done by following a so-called socio-technical system approach, which I will now introduce. Next slide, please. So we decided to follow the socio-technical system approach. Thereby we use the framework of so-called multi-level perspectives. Looks very complicated, but it's quite easy. Worldwide, this has developed as a prominent approach that analyzes transition systems at 3 levels: the niches, the regimes, and the landscape. The first level are niches, the red color. Those are protected spaces for sustainability innovations to emerge. The second level is the one of the regimes. These are institutional and societal structures which configure the existing system, in our case, the building regime. The third level above is the landscape. Landscape can best be described by the external and broader environment that influences regimes in the center and niches. For example, Vietnam's national and global commitments to SDGs, Sustainable Development Goals, and climate change actions would be forces influencing the landscape. So to promote sustainability within the building sector, the existing building regime has to be broken to get reconfigured by means of interventions. That's like the line you see from left to right in the center. And these interventions can be initiated from the level of niches through so-called strategic niche management approaches or from the landscape level. Next slide, please. So for us at the niche level, we contribute to promote strategic niche management through providing, for example, an in-depth case study of House Neo certified green building, one of the pioneering certified green buildings in Vietnam. We focused our survey on the user's behavior dimension and impacts of green building certification on household energy consumption and their environmental awareness. In this context, and this is very important, we could find hard evidence that green building certification really makes a significant difference in terms of energy consumption. Next slide, please. So at regime level, we initiate interventions to reconfigure the building sector through the empowerment of stakeholders. By organizing conferences and webinars like the one of today, we promote alternative discourses and facilitate multi-stakeholder dialogues. We outreach and transfer from science to society. Thereby, we also contribute to much needed capacity building and development. All these activities shall support the closing of implementation gaps in Vietnam. Next slide, please. Also at the regime level, we disseminate knowledge on sustainability solutions accessible to a general public. Through a popular catalog, a so-called handbook for green housing and healthy living, we want to promote environmentally friendly lifestyles from multidisciplinary perspectives in Vietnam based on our research of CAMaRSEC project. Next slide, please. So in regard of landscape level, we mainstream sustainable building discourses through connecting the technical engineering with social science perspective. Thereby, we support evidence-based policy making. Thereby, the establishment of a competence center of sustainable building in Vietnam, as you see the picture of the inauguration at Hanoi University of Civil Engineering in October 2019, would be an institutional innovation to provide and to bundle multidisciplinary knowledge and to apply cross-cutting approaches among, for example, all faculties of Hanoi University of Civil Engineering. So next slide, please. Coming to my conclusion, I would say that firstly, we observe an apparent mismatch between the various policies of Vietnam green building landscape and the real developments, which show a lack of implementation of sustainability efforts. Secondly, we strongly maintain that an inclusion of the social science, so my science, is required to reconfigure current development pathways in Vietnam. Only if we do it, a really transformative change can be achieved. This can only happen through more people-led governance approaches from our perspective. Thirdly, we just suggest a mix of different strategic niche management approaches, such as facilitating new institutional innovations or supporting evidence-based policy making to foster this transformative change. Fourthly, we strongly advocate to pay more regard of behavior aspects and to initiate multi-stakeholder dialogues by means of interventions. This will support successfully closing implementation gaps of Vietnam's building regime. And last but not least, also based on my personal experience in Vietnam of the past 25 years, since 1996 already, I want to highlight the importance of intensive communication and of dissemination efforts, transfer from science to society. These efforts are required to implement cross-cutting solutions and to successfully break away with silo mentalities, also between engineering and social sciences. Next and final slide, please. So the whole team of Sub-Project 2 would like to thank a lot for the fruitful cooperation in the past And we are very much looking forward to continue our joint efforts with MUSE, hopefully, in the future. So thanks a lot for your kind attention. Much appreciated. Thanks so much. So this is my input. Thanks for TUI for preparing this together with me. Let's switch to the next presentation, please, from Professor Künzel from Fraunhofer Institute of Building Physics, CAMaRSEC sub-project number 3. So Hartwig, the floor is yours.
Thank you, Michael. Good morning, ladies and gentlemen. It's a pleasure to talk today, to present today our work task that we have in the CAMaRSEC project, where we are really closely collaborating with VIBM in Hanoi. We have realized in our history, and we are doing field tests at our institute for 70 years now, laboratory tests for 90 years, computer simulations for about 25 years. And we have realized that all the heat and moisture transfer phenomena not only determine the energy performance of buildings and construction components, but also the durability. Most of the damage or degradation that we find is related to the combination of heat and moisture. And therefore, we have realized that it's very important to understand these phenomena, to analyze them in order to do something against that, in order to find solutions. And that's the reason why we are doing field tests, laboratory tests, and computer simulations. The good thing about computer simulations is that they are much faster than field tests and much cheaper too. Yeah, and therefore, and you will see afterwards, there are also other opportunities connected to simulations. That is, when we do a field test, we will know exactly how a construction component is doing in our climate here. But we won't know anything about it, how it will perform in the Vietnamese climate zones, which are much more warm and humid. So therefore, also the computer simulations can help us there. So that's the reason why within this project, together with VIBM, we tried to set up a field test building similar to what we are doing in Germany, just to see and have a reference how building materials and building components would perform under the climate in Vietnam. And what you can see here is that new test building that has been erected by VIBM. And our main task was to see whether non-fired wall materials would perform as well as the brick masonry, which is the traditional material, or maybe even better. And therefore, as you can see here, we have a reference. These are brick walls. We have light brick concrete walls, autoclave rating concrete walls. And on the right-hand side, where you still see that gap, that will be a lightweight construction that will be implemented there. Field tests like that are always important to have a reference, because you can do laboratory tests, you can do computer simulations, but you need to validate that. And therefore, we need that field test or field test buildings, as you can see over here. At the same time, you also need to know the characteristics of your materials. Yeah? You need to know what is their thermal conductivity, water absorption, vapor permeability, to assess the field test, but also as input data for the computer simulations. And that's the reason why at the same time, together with VIBM, we are setting up, or they are setting up, with our help, a hydrothermal laboratory, as we call it, as you can see it here. And one very important thing here is that guarded hot plate apparatus that you can see here on the right-hand side. This is necessary as the ultimate reference for thermal conductivity, because there are many different thermal conductivity tests, but if we really want to specify in a regulation the thermal conductivity that you have to meet or you have to comply with, you need a very reliable test, and that's the most reliable test that we all know. What you can see here are computer simulations, and that's probably a little bit difficult to understand. But what you see is on the y-axis, the water content. So you see when it's raining, a wall will absorb water, and then afterwards it will dry out again. And now it depends a lot on the material properties of the materials that make up the wall, how much water is absorbed, and how well they dry out again. And if what we did here, and these are simulations based on the material properties that we have tested before. And what you can see here is at the top graph shows you that water content variation at different orientations when you have a conventional brick wall. And you see the maximum is below 30 kilograms per cubic meter, which is 3% by volume and not a very high water content. At the bottom, you see the same for autoclaved aerated concrete, which could be a replacement for traditional brick masonry. And you see here, the maximum is somewhere below 150. But you can also see that the water content over a long period is much higher than with the brick walls. And this has mainly to do with the slower drying process. If you compare those graphs, you see that the drying process with autoclaved aerated concrete is much slower. So therefore, we have about 4 times the moisture content on average in there. And this might lead to degradation if we don't do anything about it. I must also say that here we used the same exterior render or mortar on the outside as we did for the brick walls, but this is probably not a very suitable choice for autoclaved aerated concrete. That means you can improve the moisture performance of such a wall made up of autoclaved aerated concrete if you just replace it with another, on the exterior side, with another render, so a rendering system that absorbs less water. I'd like to come to the conclusions and the outlook. I think we have seen that the new laboratory facilities that we have installed together with IBM for measuring the thermal conductivity are really important to have reliable data. Also to see whether the materials really fulfill the requirements of the Vietnamese Energy Code. We have also installed together with IBM that outdoor test stand, because that should confirm the overall performance of the envelope systems. We can do a lot of simulations, but we need to be sure that what we have simulated will also happen in practice. I think what's also important is that when you have really experimentally validated numerical simulation tools, then it's much easier for you to analyze the dynamic behavior, temperature, and the dynamic temperature moisture conditions. And then you know better what the results would be, what the effect would be, first of all, of energy demand, of comfort, and durability, because that's very important. If we want to build sustainable buildings, then they need to be very durable. The good thing about the simulations is also that you can not only predict the impact of the moisture transport properties and also of material variance, because this allows you to see what would be the necessary target values for good performance. And once you know that, then you can develop your materials in that way. What's also important is because now we have that field test stand in Hanoi, but you have different climate zones in Vietnam. Sometimes they're very different. You have mountains, you have others. Please go back to the conclusions. And therefore, it's important to know what difference would that make to have a different exterior climate. Now, you can see whether the performance will still be okay or not.
We go back to the conclusions, please.
If you have different building operation, let's say either a normal residential building, an office building, or maybe some construction or some production site where you have different indoor climate conditions, that you can also assess what that would mean for the performance of the whole building. And in the end, I just want to stress again, energy and moisture performance of materials, of building components and whole buildings must always be considered together in order to prevent damage or material degradation and also to prevent the waste of energy.
Thank you, Hartwig, for this very insightful and highly interesting presentation from Fraunhofer together with Vietnam Institute of Building Materials. So we continue with our webinar and switch to a presentation by Mr. Andreas Kruner from the German International Corporation, explaining about a PEEP program. So Andreas, you are here, I guess. And I
yes,
would
I
like
hope you can hear me. Can you hear me, Mike?
I can hear you very well, and I would allow to give the floor to you. Thanks so much.
Yes, thanks a lot. I switched on my camera. I hope you can see me as well. Yeah, perfect. Yeah, first of all, thank you very much for inviting the Program for Energy Efficiency in Buildings to your webinar. And also, first of all, I would say this presentation was planned to be done by my colleague, Mrs. Kim Tua, our senior advisor from GIZ's Program for Energy Efficiency Buildings in Hanoi, but unfortunately, she cannot join us today for some personal matters. Yeah. Okay, yeah, I wanted to present you briefly our activities in our program. I was wondering a little bit, the topic is green buildings in the coastal areas of central Vietnam. We are not directly working on this topic, no, but nevertheless, in our program, we work at the national level, supporting in Vietnam the Ministry of Environment and Natural Resources and the Ministry of Construction. Our program is a global program initiated by the German Ministry of Environment, BMU, and implemented by GIZ, and it's also commissioned by the French government. So we are cooperating together with the French Development Bank, AFD, and French ADEME, the Energy Environment Agency. Yeah, and it's all about supporting the national policy in Vietnam on improving or setting NDC targets, nationally determined contributions for the buildings and construction sector. We work very closely with MOC, the Ministry of Construction, but as well with contacts with the State Bank of Vietnam, the Vietnam Real Estate Association, and we had lots of exchange with housing developers who are implementing policy. Our program combines technical assistance to the Vietnamese government and financial assistance. So that is, let's say, the special thing about our program, that we want to prepare finance at large scale, developing national initiatives, national programs. The next slide, please. Let's have a look at the next one. If you look at Vietnam, maybe not going too much into detail, I mean, we are all aware a little bit about the challenges. The building sector and construction matters, of course, if you talk about mitigation targets at national level. Big contributions can be done. We can see there the typical technical challenges, that knowledge is lacking here and there. Talking to developers, so sometimes the understanding or knowledge of the whole house approach, building shell, technology, user behavior, all those, there are fields for getting more insights and knowledge. Investors usually lack a little bit the incentives. Why should they build better and do more for better buildings? So here we try to get into dialogue and push what can be done to make finance offers more attractive and to engage the private sector in taking more action. And yes, the regulations, it has been said before, there's an energy efficiency building code, but so far it only addresses large consumers of energy, large buildings, more than 2,500 square meters, and control mechanisms are not so great so far. What we are building on is on Vietnam's action plan for the implementation of the Paris Agreement on climate change, supporting this action. And what we have done so far is we have developed with MOC one NDC buildings roadmap for the buildings and construction sector to take action in the mid and long term towards 2050. Next slide, please. What is this about? The NDC building roadmap. We are cooperating in PEEP also very closely to the Global Alliance for Buildings and Construction. Some of you may know an international initiative based in Paris, which combines government, private sector, NGO, a lot of stakeholders to push globally action towards green buildings and to initiate the building transition. And Global ABC developed with the International Energy Agency 3 years back methodologies for roadmaps to take action in a broader scale. And they developed roadmaps for Asia, for Africa, for Latin America, so regional roadmaps. And from PEEP, we have built on this methodology 2 years back. Please, the next, click one more. Yeah, thank you. And we we went to Bangkok to regional conference with Global ABC, discussing the regional Asia roadmap, and came back to Hanoi with the idea, let's develop the NDC roadmap for Vietnam. And we started 1.5 years back with stakeholder consultations. It was just the time COVID started, so a bit challenging with a lot of virtual stakeholder consultations and coordination, developing the roadmap. And we had also an international stakeholder consultation with experts from Asia and around the world. And just now for the COP26, this draft roadmap is finished and it's being revised at MOC. And we are discussing with MOC as well how to set up an effective governance structure to coordinate such a complex sector as the building sector, where you have academic stakeholders, the private sector, many different ministries. There's not only one which is responsible for buildings and construction. Next slide, please. Just a quick look what this is about. The buildings roadmap is structuring the buildings and construction sector into, I would say, digestible work packages or actions. We are looking at urban planning and development, at new buildings, all the new construction, building retrofits, and building operations and systems. How can energy be saved or mitigation achieved during building operation? The materials, embodied carbon, that's where we are in the CAMaRSEC project as well. Building with embodied carbon materials to get this addressed, and resilience and clean energy, to use renewable energy for buildings. So the roadmap, we can share this after the webinar. You're invited to have a look, of course, comment, is proposing actions for on the short term to 2030, midterm 2040 and 2050, how to improve policies in each of these 8 action areas, and to get more ambitious and more specific over time. What we encountered, of course, is the challenge everybody has, a lack of data. How can you simulate actually baselines? What is the current mitigation baseline for different building types? So here we could only do some assumptions for the housing sector, for example, but we say we have to start taking action and gather data over time when implementation goes on, and then getting more solid every time. This NDC roadmap is a holistic approach. The idea is not having one document in the end, but a steering instrument which is regularly updated and used for orientation and measuring, monitoring action. The next one, please. 2 initial actions, just shortly to mention. Vietnam intends to go with NDC actions towards commercial buildings. There's the projected target of addressing 200 green buildings to be certified by 2030. Commercial buildings and service departments, large complex buildings we know, which are in Hanoi, Ho Chi Minh, in the big cities. And the approach is to enforce the energy efficient building code gradually to all new constructed buildings, and develop a benchmarking system for typical commercial buildings. The next slide, please. And housing, this is what we are pushing since 1.5 years from PEEP side, is developing a large national green housing program together with AFD and MOC. So far, we have done a technical feasibility study, and AFD is now starting next year a financial feasibility study. The focus is the strong construction segment of the mid-income housing sector, which is booming everywhere all over Vietnam. And addressing the young urban families who are in urgent need of apartments, who the interesting part is who also have a certain purchase power, let's say, to buy apartments, where a bit more ambitious actions can be done for green buildings. If you address only social housing, let's say, of course it's urgent, but you cannot do so much in the beginning. No? But the hope or the approach is addressing the mid-income segment and having spillover effects over time towards lower and higher income groups. No? So that's where we stand at the moment. Next year, we want to go deeper in defining more actions for the housing sector, building on this NDC roadmap. For example, there's this apartment code for housing construction to look at this, how to improve it, make it greener, and push for financing with AFD to initiate such a large program. One last comment, last sentence. Next year, also at PEEP, we are planning one larger study with Global ABC on embodied carbon, not only in Vietnam, but internationally. So we will analyze approaches for green cement, green steel, what materials should be used in which building zone. So at the moment, it's just starting this work, but also I'm inviting already now you, the CAMaRSEC project, to join. We will have peer reviews later on with your experience. I think this would be very valuable to support us in this work. Yeah, thank you very much.
Thank you, Andreas, for your very concise presentation. Actually, our focus in our case study of House Neo was also young families and lower middle income segment, and we could prove with hard evidence that households in that EDGE certified buildings save 37% of electricity or power consumption compared to conventionally constructed building. And we hope this message will lead to a further mainstreaming of this green buildings in Vietnam. Very interesting presentation, and it would be great to find more potentials to connect like the donor funded projects with science, academic projects. And I'm very glad that you joined our session, our webinar today, Andreas. So let's move on.
You.
You're welcome. With the next presentation, Ms. An unfortunately cannot join due to time constraints. So we switch now to presentations from Mutze. And the first presentation from Mutze, you get some short insight, but we will share the whole presentation later on, no, too far, would be Mr. Phuong, Rector of Min Chung University of Civil Engineering. Mr. Phuong, the floor is yours. We are very much looking to your input.
Trong khuôn khổ của cái hội thảo với thời gian là 10 phút thì tôi cũng xin.
In the scope of the seminar, within 10 minutes, I would like to present on the challenges and opportunities to promote sustainable buildings in Central Vietnam from urban planning and urbanization prospect. In my presentation, there will be three main parts. First, the features of central coastal cities in Vietnam, some issues of response to climate change, sea level rise, and extreme weather in the planning of coastal cities in Vietnam. The second part will be on the developing green buildings in the coastal areas of central Vietnam. Over the past 3 years, working at the MUC and the MUSE, I have participated in some of the projects and research, and in the training process, I can see the differences between various cities in the coastal central Vietnam from cities in the north and the south, like Hanoi and Ho Chi Minh cities. It's related to the green building, green architecture, and a lot of issues are related to climate change, and we need to pay more attention to climate change and respond to extreme weather conditions. Through the presentations and as that we have just listened in this webinar, if you expand your activities and research to the central area, it would be great. MUSE, our university MUSE, we would be willing to be a partner with you for those activities. And we hope that there will be collaboration in planning or regarding architecture regarding building materials. We look forward to the partnership and collaboration with you. Before we did have collaboration projects, but they are just like a small projects. But we hope this will be more comprehensive. And now I would like to introduce to you about the characteristic of the urban system in the central coastal region. As you can see that the central coast of Vietnam, right from Thanh Hóa to Bình Thuận provinces along the coastline. These are the images that you can see. In here we have the urban area type 1 and type 2 and the smaller scales. In the cities in central coastal areas can be divided into the northern central part and the southern central part and the central highland. In the central coastal areas, you can be divided into 3 different parts: the northern central part, the middle central part, and the southern central part in terms of climate. So this classification would be meaningful to green and sustainable buildings. A very distinctive feature of the central region is the changes in temperature. And the second thing is changes in the rainfall, and especially in the sea level rise. For example, 2 weeks ago in Phú Yên, in province, for many years, last year we went through a big flooding. The cause for that in the media and many people talked about it. It's because of the rainfall. But the thing is that the point in time of the rain is later than usual. So the hydropower plant was not ready for that. This is a content that I have just introduced. We have a lot of things in the legal framework related to climate change in urban planning. Recently, we participated in projects to adjust the city master plan of central coastal cities that have some content related to green building. Regarding green buildings, next slide. Yeah, it's fine now. In the research, you can see that potential for green building development in the central area of Vietnam, especially in the southern central Vietnam, is a lot, especially with the wind and the temperature features here. As you can see, the average temperature here, you can see the range of the temperature on average. As you can see the temperature in the northern part and the wind speed. So the beneficial value is north is in Nha Trang is like 90 hours per year. So you can see that the southern central area is really relevant for the research of developing green buildings. The South Central region has a very suitable climate for researching sustainable architectural solutions like green buildings. And the main experimental results are traditional architectural works. And the southern central coastal cities are typical objects for green buildings and sustainable solutions. As you can see on the image, some of the solution that in Phú Yên province, like the double roof house, like the stilt house at the bottom of the screen. You can see that the stilt house is relevant for the purpose where the local residents live in the frequently flooded areas, and these materials are sustainable. Another some solutions for developing green building in central coastal Vietnam. First are the solutions to include the following: the solution for planning a building to reduce solar radiation, the structural solutions for sun protection, a natural ventilation solution, a solution for wall and roof insulation, the facade solution, including solid and hollow, reducing glazing in adverse directions, or the solution using climate-adapted material, unburnt materials, or solution using renewable energy, a solution to save water and use low E-class, and integrated solution response to climate change and extreme weather. As you can see, these are solutions for developing green building in the urban coastal areas of Vietnam. These are some of the examples in some of the characteristics of the central coastal areas. Here we can see the lessons from international experience and domestic one. For example, in Denmark, or the UAE, these are the people, the places that I have visited and learned a lot from them. I also Germany I have already visited, but I would wait to hear more from our German experts and colleagues. Regarding architecture, I would like to introduce some of the construction that we are building in the Muse. Is first is a multifunctional building in Da Nang, and the second one is a library. Even though this is a public, these are public projects with very limited funding, but we let our students to consider the solutions for these projects, and we try to address issues like thermal radiation or the ventilation solutions to reduce the use of air conditioner, as well as take advantage of the natural space to get the natural ventilation in certain location. Regarding material, we try to use a non-fired brick. So we try to use the more economical solutions. I hope that I have a suggestion for the CAMaRSEC projects that you may consider what kind of material would be best and optimal to be used, which is affordable in the central coastal areas. So that, and then you can organize like training courses or opportunities to elaborate or to transfer the expertise and the knowledge to the people in the area. At our university, we focus on, we do prioritize the focusing on sustainable material and sustainable building because we care a lot about climate change. In our training, in our curriculum, in the current curriculum, we have different software solutions for architectural and infrastructures constructions. But recently, we integrate the content about the ecology of BIM applications. And we are planning to integrate this content into the training curriculum for year 2021 to 2025. At the moment, we are conducting the TOT training for our teachers at the university, and consider ways to develop a comprehensive part of the curriculum regarding this content for our students, so that the student can be equipped more with the knowledge and expertise of green building and sustainable building. I hope that our collaboration with the German partner on green building can be, you can elaborate and transfer your expertise on green building to us to be included in our training curriculum. To conclude, the Central Vietnam coastal cities have many opportunities for green building development. However, there's one thing that we need to pay more attention to in this area is the extreme weather condition and the sea level rise. At MIL, we have the expertise and the expert who were trained abroad and have the capacity to conduct certain kinds of projects and experiments. I myself can be a part of such experiments and projects and research too in the central Vietnam, from Da Nang to Phú Yên and further. Thank you very much for your attention. Thank you.
Thank you so much for your excellent and very comprehensive presentation. And it would be really perfect if we can further explore potentials to cooperate with you and staff from your school in the future. So let's continue with the next presentation with a colleague from MUTSE. This would be Mr. Hien, Head of Faculty of Architecture. You are muted, no? You are muted.
Present my presentation on the spatial organization of coastal village of Southern Central region towards sustainable development and adaptation to climate change. I will present a solution to be applied in a specific area, which is in the certain central area. Later on, I will introduce to you about the research site. There are the 5 characteristics of this spatial of the coastal village. First is we build an overall village. Second, we organize an architectural space landscape, and then we apply the green technologies to be suitable to the development of the buildings here. The fourth one is that we create a green network of water service to be suitable to the environmental features of the central region. And finally, are the solutions for climate change adaptation in the spatial organization. The things that need to be integrated in our research is the balance of economic and ecological aspects, and the adaptability to climate change, and thirdly is the linkage of ecosystems. Regarding the location of our research, the central coastal region, the southern central coast area, we include 8 provinces, including the coastal sand dunes on the long river flow parallel to the coast, and the fishermen will settle around the estuaries and form fishing villages. They reside on the land and have their own living custom and lifestyles. They're located is marked on the map, as you can see. Our research location area include Bình Định, Phú Yên, and Khánh Hòa provinces, including the people who live in the villages along the coastline, and they live on the distinctive livelihoods for coastal residents. The first part, among the 5 components of coastal villages, the first one is the overall orientation. This orientation will be built based on circumstances of the natural, the culture, and the distinctive features of each region. The second part is the changes in designing, renovating, constructing, and managing these housing projects. And thirdly, we have to form a variety of links to attract different resources to invest in. The organizations of the spatial architecture we will look at the specific living area of the inhabitants, especially around the estuaries. The fishing villages are organized into clusters of villages in which you can see the component like coastal landmass, the sea surface area, or the semi-submerged space where the tidal will the tides will go ups and down according to the time in the day or the month. Regarding the spatial structure of the fishing village, for example, we have the fishing village in Tam Quan, Balin, and Phú Ngân, and they have their own distinctive types of livelihood and different kind of economic activities for livelihood. In our research, we need to identify job livelihood that can be sustainable in the long run for them to live on. Regarding the cluster of villages, they would have from 5 to 10 villages around in a certain small area like estuaries, river mouth, or a Gulf area. Center is about 250 to 500 hectares in area. And these clusters of coastal villages have different functions, including the water surface for services for commerce or aquaculture. For each cluster, we have to make clear what is the purpose of the function of each spatial structures area. Apart from that, there should be a central area for each cluster. We have to identify which area, which zone that should be preserved, like the conservation area. When we have the research, then we would identify specifically which area would be the conservation one. The third thing is that we will apply the green technologies for buildings. The previous slide, please. The concept of agri and fishing, agriculture and fisheries village, including the producing of biomass and natural power and the integral resource processing and the issue related to recycling, use of energy and material. We have these areas have potential for solar power and wind power. We also have green. We also have biogas here from resource here from agricultural farming or from the waste treatment from farming and agriculture and fisheries. Have green energy here. We can create the green water surface to make sure that the construction can be more sustainable and the environment, and hopefully the environment could be less harsh for the inhabitants. The fifth issue is on climate change adaptation. We identify into different spatial area for the villages. Each zones will have their own distinctive characteristics. So we have to identify different ways to adapt to climate change in that zone. For example, the like ABA, like eco solutions, or we can expand the green spaces for tree planting, tree growing, or the zone where we preserve the biodiversity. Regarding the estuary villages, then we will have certain zones for conservation of the cultural values and at the same time respond well to climate change, like adapt well to climate changes, so that we can preserve the result of construction for a long time, especially in the a certain area. They are vulnerable to weather factors like tidal regime or strong wind, etc. So we need to have climate change adaptation structures and sustainable one. And for certain construction, we have to accept that it cannot be regenerated if it is the damage is too serious. For conclusion, we need to have a model of spatial organization for fishermen, for fishermen's villages. Spaces would affect each other. These spaces interact with each other, forming the axis of development and interference space. And the marine spaces with diverse function, essential for the sustainable development of fishing villages and marine economic strategies. The interspace spaces, together with the coastal ecosystem, is one of the preconditions for adaptation to climate change and sea level rise. This can be just a part of a bigger context. I hope that through this project we can find out the solution, the sustainable solution for the fishermen villages in the southern central.
Thanks for your very instructive and interesting presentation. Much appreciated. So we switch to the next presentation from Ms. Tu from the International Cooperation and Research Administration Office of MUTSE. Ms. Tu, I'm very glad that we have the opportunity to hear your presentation now. The floor is yours.
Ladies and gentlemen, thank you very much for the invitation of Dr. Michael from Hamburg University to give me a chance to present to you on the resilient housing to natural extreme event in the coastal central region of Vietnam. As you may have already known, the impact of flood and storm in this area is huge. Every year, we have to go through about 5 to 6 storms and 2 to 3 tropical depressions, and a big flood every 4 to 6 years. And in the slides, you can see the images of some of the strong typhoons and that hit Vietnam over the past 70 years. And majority of them hit the central coastal area of Vietnam. Next slide. And this area is also vulnerable to sea level rise phenomenon. In 2019, our university responded to a call for UNDP competition in collaboration with UNDP on designing the safe and resilient houses for that can be adapted to the climate in the coastal areas. We at our university we respond to that by organizing the competition at the university level, and we identify and the 3 locations for survey, including the Blanc village, which is highly severely vulnerable to the impact of the oceans activities. And the second one is the Ruhr village. And thirdly, the third one is the Long Thủy village. The Ruhr village and Long Thủy village are both vulnerable to the oceans the ocean factors phenomena. So we conducted a study to see the impact of the climate change on these areas in the changes of the topography according to the seasons in the years and across the years. When we conduct this study, the previous slide, please, Mr. Lee. When we conduct this research, we collaborated with 3 other research. We conducted the site analysis, the document analysis, and the interviews with the inhabitants in these villages. And as a result, these are our findings and observations. The people's vulnerability will rise due to their living and housing condition. Under the same weather conditions, the group of population who live in temporary houses, what we call like weak house structure, then they are more vulnerable to extreme weather condition like big storms or big flooding. For example, due to the flooded basic facilities like roads, and the only way during the big flooding, then the only way to get access to them is through boats. These residence houses are also isolated during big, and the way for people to prevent the damage of extreme weather condition is very simple and manual ones, like putting bags of sand on the rooftop, or to put some stick to reinforce their doors, etc. And so these residents do have the wish to have more solid and stronger reinforced houses to keep them safe from storms, big storms, and flooding. These are some images of Ngọc Lãng village under the impact of the river water in Ngọc Lãng village. You can see that at the peak of flood level in 1999, like the whole village of Ngọc Lãng were submerged underwater. So this is the record high flooding. So the flooding water level was 4 meters, which is record high. We put forward we proposed models to help the resilient adapt better to climate change and natural disasters. We first is the Habitat Levy model for Ngọc Lãng villages, which is highly vulnerable to strong typhoons and floodings. So you can see the ecological park and the community gardens and the agricultural space. So you can see different layers of the outer one and the inner one. For the regenerated houses, the houses should have a garden in the front, so that it would be easier for the authority to reach out to them for any kind of assistance and help during natural disasters time, and also the linkage with the neighboring areas like a bridge and a bridge or the road to connect with the Tuy Hòa city in the adjacent area, so that it can be more convenient for evacuation in case of natural disasters for the residents. We also propose some house models to be more resilient to floods and storms. We have many models, but in the frame of this presentation, I would introduce just a few models that we have. These models are based on the traditional structure, but we do have certain kind of adjustment. Like the kitchen have a special structure where the kitchen can be floating on the flooding water, and it can be moved sideways to connect the kitchens of 2 houses together during a strong big flooding, so that the 2 kitchens of the 2 houses can reinforce each other. And the material that we propose to use is a lightweight one in combination with the floating part, so that it can be floating during flooding time. Another thing that we get is a proposal from a group of students of our university. For this solution, they won the first prize in our competition. They propose additional structure for the existing houses. As you can see, the red color on this in the images on the screen. So these structures can be resilient to strong storms, and the households residents can hide in these red structures during time. And another issue that is important during flooding time is the supply of clean and safe water and power. And so, as you may have known, like during heavy flooding, then the power will be cut and the clean water supply will be cut too. So that is the reason why a solution that we proposed is that there will be an area to preserve rainwater for use, and also the installation of certain solar panels for the local resident can have a certain kind of power source during flooding time. And they can combine these structures with the existing houses or to be installed into new houses in the residential area. From the result of the competition, we continue to do research and propose other housing models. These models are ideal for storm and flood resilience. However, due to the limitation of cost and the habit of the residents, of the inhabitants in the local area who are used to living in detached houses. So we put forward models to meet their demands, and different models for them to choose from. For example, for an area of 3.5 meter area for the house to be built on. We also propose different solutions for design and technology. For example, the FC technologies, which is eco-friendly and economical. However, due to COVID-19 pandemic impact, as well as the limitation of the university in implementation, we still need time and more funding to test this solution. In the finally, we conducted the conditions flooding in Tuy Hòa from in December, this month, from to the 3rd to the 12th of December this month. We think that the solution should be conducted at the community level, and there should be solution to enhance the natural disasters resilience of houses. And during natural disasters, like as you can see, most of the houses of the inhabitants are isolated. So that is the reason why that the design of the future houses should be convenient for evacuation and rescues during natural disaster time. And we also have to pay attention to the solution that can be affordable and cheap, so that it can be affordable for the local residents. So the house must be safe, sustainable, and also affordable. So thank you very much for your attention to my presentation. Thank you.
Thank you too for this very interesting presentation. I like that you also pay regard to socio-economic aspects like affordability. Resilient housing is a very important topic, and there will be a future call from the Funding Ministry of Education and Research Germany on the topic of risk management and resilient housing. in which we might cooperate in the future. So looking very much forward to this. I would now like to switch on to the last presentation from our colleagues from MUTSE, and this presentation will be done by Dr. Viet from the Center of Professional Training and Experiments. So, Mr. Viet, I would like to invite you to present now.
Yes, thank you very much for your introduction of Dr. Michael. So, hello everyone. My name is Dang Viet. Now I'm a lecturer at the Miền Trung University of Civil Engineering. So I'm the honor to have the opportunity today to talk about my research with the title of the eco-friendly concrete incorporating of supplementary cemented material at the coastal area. So as you know, the concrete is one of the most important material for the construction, consisting of the cement, water, cold aggregate, and fire aggregate. So the rapid development in the building and civil infrastructure lead to the increase in the demand of the concrete, resulting in the over-exploitation of the fire aggregate, such as the river sand. Therefore, as one of the alternative material, the CSAN is recommended to use as fire aggregate for concrete production because it's very abundant at the coastal area. So one of the major contributors to the carbon dioxide emission in the cement production, it affects to the climate change and the global warming. So it is reported that around 4 billion tons of the cement produced every year all over the world, and around 1 ton of the carbon dioxide is emitted to produce 1 ton of the cement. Therefore, to eliminate the effect of the cement production on the climate change, the use of blend cement with supplementary cemented material is widely used in the cement and concrete construction. Regarding the, regarding the supplementary cemented material, we can see that the fly ash and blast furnace slag is the commonly used material and can improve the performance of the concrete. Therefore, in this study is investigate the performance of the concrete by using the CSAN without the desalination and the fly ash as well as the blast furnace slag as sustainable cemented material. So, please move to the next slide. So, in my research, the cemented material yield were ordinary Portland cement, fly ash, and blast furnace slag. And regarding the aggregate, there include the cold aggregate and 2 types of fire aggregate in terms of the non-destructive CSAN and destructive CSAN. Yes. So, and the water, what the water used in this study is the fresh water. Please, rest. And the signature proportions were repaired with constant of the water to cemented material of 0.5 in this study. And ordinarily, Portland cement were partially related with 15% fly ash and 45% of blast furnace slag by mass in my research. Please move to the next slide. So after mixing, the fresh concrete were poured into the cylindrical mold to determine the property of the hardened concrete. On the surface of the specimen was sealed with aluminum tape to prevent the excessive water evaporation and the carbonation. So the concrete strength and the subtlety of the concrete were determined because they were the common characteristics which can reflect the mechanical property and durability of the concrete. And they were measured up to the age of the 182 days. Please move to the next slide. So regarding to the result, it can be seen that the concrete strength of the on-concrete mixture still increased with the cement hydration. And after 182 days, the concrete strength of the concrete using the non-destructive CSAN were almost the same at thus using the resource decision regardless of the fly ash and blast furnace slag releasement. And it can be seen that the releasement of fly ash and blast furnace slag just reduce the complete strength at the 3 day. However, at 182 days, the complete strength of fly ash and blast furnace slag concrete was slightly higher than the ordinary Portland cement concrete. Please move to the next slide. Yes. Regarding the result of the subtivities, we can be seen that the subtivity coefficient of the on-concrete will continue at least decrease with the time. And it is clearly that the non-decision concrete has the lower subtivity coefficient than the resource decision concrete regardless of the curing age or fly ash and blast furnace slag releasement. And it can be seen that the concrete incorporating of the fly ash and blast furnace slag show the significantly lower subtivity coefficient compared to the ordinary Portland cement concrete after 182 days. Please move to the next slide. And beyond the database, we were reported by the Japanese Cement Association on the 2018. The carbon dioxide emission for the 1 cubic meter of the concrete can be calculated, and we can be seen from the table. And the results show that the replacement of ordinary Portland cement by 15% flat and 45% blast furnace slag can reduce the around 14% and 43% of the carbon dioxide emissions, respectively. Meanwhile, the complete strength of the concrete containing the flat and blast furnace slag work ensure. Please move back to slide. Yes, we can see figure on the right side. The complete strength of concrete containing flat and blast furnace slag can be ensured or even slightly higher than that of ordinary Portland cement concrete after 182 days. So please move to the next slide. Yes, but so beyond the result I obtained from my research, generally it can be concluded that the non-resource decision could be considered as the potential fire aggregate for concrete production at the coastal area. In addition, the flat and blast furnace slag utilization for material replacement of ordinary Portland cement had a benefit in not only securing the complete strength of the concrete and stability of the concrete after 182 days, but also significantly reducing the carbon dioxide emission. So because it is due to the limited time, so I just showed a short brief my results. So thank you very much for your kind attention. Yes, this is on my presentations. Yeah.
Thank you, Mr. Viet. You even presented in English language. You could have done it in Vietnamese. Much appreciated, easier to understand for us. It's really amazing that these alternatives to concrete have such a tremendously better carbon emission balance compared to the traditional concrete. So this maybe is also interesting for Hartwig and his colleagues, because he's the expert on building materials. So maybe this is also now a good transition to move to the open discussion, which will be moderated by my colleague Tui. Please go on with the slide. So Tui, the floor is yours.
Yes, thank you, Michael. Thank you to all presenters and for very, very interesting and insightful presentations. Now I would like to open the floor to the audience, to every participant for further discussion. Obviously we can see that there are challenges that we all have to face, and but the important thing is that we learn from that and we become stronger and always keep positive and collaborate with each other to overcome the challenges, right? And definitely the presentations and insights from people show that there are so many opportunities for us to move forward and explore our further collaboration between CAMaRSEC and CAMaRSEC, and also other partners in Vietnam. So please continue the discussion and share your thoughts and comments. And if you have questions, please feel free to ask our presenters.
Maybe we stop the screen sharing for a moment, then we can see each other a bit better.
Yes, that's a good idea. Thank you. And I saw Professor Kunze. Please share our...
Thank you. I would have a question to the last presentation with that the salt from the sand from the sea, and there are probably salts involved in there. I've seen that they have quite a good mechanical performance and everything, but I don't know whether you know anything about the durability, whether there are any durability issues involved in using sand from the seaside because of the chlorides or something like that. Do you have any ideas about that?
Yeah, thank you very much for your question. So this in my presentation, this result I got from my PhD program, and it's already published in the to Juno. So because based on my result, I recommend to use the season for the concrete, especially for the concrete used for block concrete used for the breakwater at the coastal area. Because now in Vietnam, due to the climate change, so now more and more the breakwater has been built along the beach of the Vietnam. But in Vietnam, the season now is limited. But from the result, from my result, I recommend to use the season for the plain concrete without the steel reinforcement, because the salt in the season it benefit. It can contribute to the increase in the mechanical properties such as concrete strength and modulus of elasticity. Because due to the presence of the chloride, this is one kind of salt in the season. It can combine and form the one kind of the phase. This is aluminate chlorua. We can call it the fredo-salt. And the formation of fredo-salt can contribute to the increase in the mechanical property of the concrete. This I have the evidence from the my research.
Thank you very much.
I recommend to use the season for the first for the non-steel, non-reinforced concrete structure. This plain concrete. Yes.
I totally agree. Thank you.
Thank you. Thank you, Mr. Viet. Thank you, Professor Kunze. I saw Dirk raised your hand, right? Could you like to share something?
Yes, thank you for giving me the word. I just wanted to comment also on the salt and the steel in the concrete, that there might be some implications, but I think that was discussed in the answer.
Okay, thanks. Any other participants who would like to share your thoughts and comments or questions for clarification?
I would like to ask Ms. Tu again about the UNDP project. Is it still ongoing or is it finished by now? And what would be like a follow-up strategy from your perspective to promote resilient housing in central Vietnam based on your previous experience?
Ms. Tu, are you there?
Xin cảm ơn chị Thủy đã hỏi. Thì hiện nay
thank you, Ms. Thủy and Mr. Michael for your question. Regarding the UNDP project, due to COVID-19, we temporarily stopped the project, but we are looking forward to the possibility to continue this initiative to build affordable, resilient houses. I would like to add more information about that project. Regarding the UNDP projects, after the after the first phase, in the second phase, they will pilot some structures in Phú Yên, and we will collaborate with them to do this. The challenge here is the use of what kind of material to use. We suggest the use of lightweight concrete, but from the research perspective, it is good. However, for mass production of lightweight concrete, it could be a challenge for us regarding equipment and facilities. For UNDP, they need more time to validate the solution. And for us, at the moment, we are conducting the projects from the conventional approach, which means that we use a conventional concrete and not the new material within this project, within our project. But from our discussion with the German expert, you mentioned a lot about material research on building materials. But from hearing your presentation, I think it's more relevant to residential buildings and commercial buildings. For houses that can be green and it can be natural disaster resilient. Do you have any experience or expertise on this? We could look forward to hearing your sharing. Thank you, Dr. Phương.
The German partners, Professor Kunzel or Dr. Schroeder?
Yes, I think we focus in our CAMaRSEC project, which is the title or the topic today, on the use of high-rise residential buildings and so on. There is another project ongoing, which is also interesting. It's our REBUMAT project, where we look at resource-efficient materials, and there we discuss more deep in the topics of concrete, of non-fired bricks, and so on, and also on the application of lightweight materials, of bio-based materials, and so on. We could also include this project. It's also funded by the Federal Ministry of Education and Research, and we see it as complementary to the CAMaRSEC project. I think that there are some insights into that which are more technical,
So as we can understand that the typical condition for the construction sector in Miền Trung, in the central area of Vietnam, is really to consider the climate and geographical conditions, right, in all the life cycles of the building matter. So we hopefully that after this event we can continue with further kind of bilateral communication or discussion between universities of CAMaRSEC project and in the MUSE in Vietnam.
Mr. Viet has raised his hand. Mr. Viet has raised his hand.
Yes, please.
Sorry, can I have a question regarding the presentation related to the heat and the moisture transfer? Because I'm very interested in this experiment. So can you say more detail regarding the experiment of the heat and the moisture transfer at the test site of the building? The maximum of the temperature in this experiment.
May I answer? You asked about the maximum temperature that we are using.
Yes.
Actually, it depends on the outdoor climate, more or less, because indoors we try to maintain comfortable conditions. So probably maximum 25 degrees C or something like that. We might even go a little bit further down, because then the conditions are even more severe for the building component. Yeah? And the outside temperature just depends on the solar radiation, the temperature and so on. So that will influence the surface temperature on the outside. Yeah? And when we do simulations, we always take meteorological data with hourly values. That's very important, because we want to have that daily cycle between day and night, sunshine, no sunshine, rain, no rain, and so on. Does that answer the question, or did you have anything else in mind?
Thank you, Mr. Viet and Mr. Hadvit. I see a question in the chat box regarding the public awareness in terms of applying the solutions for sustainable building and also for improving resilience. Could we please address this question, I think, to Dr. Weibel? We can see that there are ongoing many different projects and initiatives on promoting sustainable building, but there are still a lot of gaps in implementing those solutions. And the question is how to promote and to upscale and also to promote the implementation of those initiatives in the wider public, to raise the people's awareness and to make the people understand that the climate change and all these kind of disaster and risks happening and impacting all single individual. What would be the more effective solution, more realistic, feasible, and applicable for implementation in reality? So that's the question.
Thanks for these questions. Of course, honestly, we cannot save the world with CAMaRSEC project, but we can advocate for more cross-cutting approaches. We, for example, would like to facilitate and promote the Competence Center for Sustainable Building, which brings together different knowledge and expertise from various departments of Hanoi University of Civil Engineering, and brings also together the corporate sector with civil society. And we can use the Competence Center for Sustainable Building to achieve this kind of outreach to the public. And of course, it has to be a bundle of different measures from awareness raising, capacity development, but we should always promote a comprehensive systemic view, because just promoting regulations as explained or just promoting a specific technology should always be combined by considering the people's mindset, people's behavior patterns. Otherwise, we won't achieve progress in sustainability. We have to reconfigure transformation pathways by a comprehensive integrated approach.
Yeah, thank you, Michael. Actually, we just some information to share that currently both Ministry of Construction and the Ministry of Natural and Environment are very well aware of the importance of raising people's awareness, and their strategies being drafted and promoted to promote this work in many different national and local actions. So that is some signs showing that the government is aware of this matter, and also the way how we disseminate the information from bringing from science to the society is also very important, and we will find a way to promote more events like this in a more effective way, and also for example, the handbook that we are developing to bring the knowledge to the public. Some part of that we are doing.
And I also see Mr. Tuan from Hanoi University of Civil Engineering in the conference right now with his background. Hello, Mr. Tuan.
Hello, everyone. Yeah, thank you,
Michael. A joint series of lectures and trainings funded by Konrad Adenauer Foundation, where we will invite also colleagues from MUTSE to present about their expertise in the year 2022 and the following years. So I see a lot of potential of cooperating with MUTSE in the future. And I think now we should and have to end our open discussion. The time is up. And I would like to hand over to the rector of MUTSE a final time to do a wrapping and to provide a closing word. Thanks so much from my side.
Kính thưa các quý vị đại biểu và kính thưa các
Ladies and gentlemen, scientists and experts, ladies and gentlemen, we have a very limited time for the webinar, but after hearing the listening to the presentations and the discussions from the German expert and from the Muse, we can see the more information about, more insight about sustainable building, green building, and also about the characteristic of constructions in the coastal central areas. And then we can also see the distinctive solutions central area related to climate change adaptation and the materials to be used that can be effective economically and can be resilient to natural disasters. I think that through this webinar today, an approach that is distinctive and suitable for the central area of Vietnam, which can be applicable for urban planning and for architectures techniques and building. There will be, we can see in the presentation, we can see a lot of information about experiments, about piloting, about technical solutions, about solutions. So we hope that it will be feasible and practical for the coastal central area in the future. We can also see that when we collaborate with the experts from the international universities, we can integrate the content into the curriculum of training curriculum at the university. And I think it's go on in line with our orientation. So we hope that through this project, when we can have a chance to get access more to work with the such expertise, especially for the Muse. One more thing that we see is that apart from the research project and the workshops, we would also try to turn our research into a practical project where we can call for funding from sponsors and turn our application of a research project to be kind of like a pilot project, and which can be conducted right on site on the campus of our university, and that will ensure the sustainable impact of the project after the project has already in the future. If you put it right on the campus of the Muse, because the Muse, at Muse, we have the collaboration, relationship, and partnership with other universities in the country too. Thank you very much for your participation, for your attention, and thank you very much to the presenters, to the experts for your presentations and your participation. Thank you very much.
Thanks for your warm words. Very, very much appreciated. I sincerely hope that there will be many opportunities to collaborate with your school in the near future. And I'm very much looking forward to this. I see one raised hand, actually, Mr. Bin from Thong Duc Tan University. If you want to share your opinion, maybe you, I give you the floor.
Dr. Michaela, I can speak in Vietnamese.
Yes.
I would like to put forward a sharing from Tôn Đức Thắng University. I highly appreciate the webinar today because this is an opportunity for me to hear of a really great ideas on sustainable building. Especially, I'm interested in Mr. Hien's presentation on the fisherman villages. I used to live in Khánh Hòa province, locality that is strong in tourism development. I think Phú Yên also has the orientation for tourism development in the near future. So I would like to put forward this idea to Mr. Hiến. When we talked about the climate change adapted solutions, well, we focus solely on climate change adaptation, but actually for sustainable construction of building, we look not only at environmental issues, but also social and economical sides. Do you consider the other two aspects in your research? And how can you solve those social and economical aspects in your research in regarding to your research for the fisherman village? Thank you.
So I would like to encourage you to keep your answer short because actually we are at the end of our webinar.
Tôi sẽ khuyến khích là tiến sĩ Hiến. Thank you for the sharing and a question from Mr. Bin from Tôn Đức Thắng University. Mr. Bin is right. Dr. Bin is right that sustainable building for fishermen village is not only about climate change adaptation. We need to pay attention to other aspects like the humanity one, the environmental one, the economic, and especially regarding the economic side for fishermen villages. We need to pay attention to the cultural developments. In social cultural development, there are many issues that we need to address so that we can raise the awareness of the local residents, so that the local residents can be aware of their cultural identities. For the fishermen villages who inhabit in the area where their livelihood is on fishing, on fisheries, and normally the natural landscape is very beautiful, then that area which has the residential values and also the natural values and also tourism values. So recently, Mr. Bin, please rest assured the local authorities already address and pay attention to these values. Environmental protection in parallel with cultural resources and identities. In the coming time, together with the material and facility and infrastructure development and planning, we would also pay attention to the preservation or conservation of the cultural values. Actually, at Muse, we prioritize in spatial organization of these fishermen villages. We prioritize the preservation of cultural values on top, and then we also look at the climate change adaptation, climate change adaptability of construction materials to be integrated well into the spatial organization of these villages. Whatever values that we want to introduce to the local residents, it must be relevant to their needs, relevant to their understanding. If the local resident don't see it fit to them, they would not agree to carry out our solutions. So I would look forward to the opportunities to collaborate with Tôn Đức Thắng University.
Thanks so much. Very active discussion, very enthusiastic participation of all of you. It was a great honor for us to host this workshop together with Mutze. Thanks a lot to Tui, who was mainly responsible for preparing and organizing this. I think it was all in all, despite the intervention, a very fruitful and interesting, inspiring event with many insightful presentations. We will send you all presentations as a PDF file later on, and we will also publish a cut and censored video of the conference and workshop in the aftermath of today's event. So thanks so much to everyone. It was again a great honor to be part of this event. And I hope and I'm convinced that we will in the future work together in a very trustful and responsible and harmonious way. Thanks so much from my side. Much appreciated. Looking very much forward to the future with all of you. Have a nice evening, a good dinner. Thanks so much.
Thank you and goodbye.
Thank you.
Thank you very much. And hope to see you in the future.
Yeah. See you then.
See you. Bye-bye.